We're now going to be looking at u substitution for definite integrals. Remember, definite integrals give us clear numbers, so we're going from a to b, so our answer should be a number. Now the difference with u substitution and definite integrals is that this a and b are things that we are supposed to substitute for x. So when I take my next step and I find my antiderivatives, it's going to be a plugging in b minus plugging in a or whatever we have there. But we plug those values in for x. If I do a substitution and put a u here, I can no longer write from a to b because a and b would then be plugged into u. They're not u values, they are x values. Well, it shouldn't be hard to do that. We can make this change because we have already decided that u is equal to something in terms of x. Say, for example, here I made u equal to ax. Then if I look, I'm going from x equal to a to x equals b, which would mean u is equal to whatever my substitution was, but changing my x for that top value. And down here, okay, so that would be my lower limit. And this one down here would be that a times whatever that is. So whatever my substitution, that will allow me to change these values. Okay, let's look at a couple of examples. In this first example, we have tangent and secant. Now the substitution I'm going to make here actually isn't really much of a substitution. We're just going to look at this tangent because I should recognize that the derivative of tangent is actually secant squared. So I'm going to let u be equal to tangent x because I see that the derivative du would be equal to secant squared x dx. So in my next step, we can do some substitutions here. We'll take all my secant squared x dx as my du, and we'll let tangent of x be u. Now I'm looking at u du. This is where we need to be careful because a lot of students will either abandon these numbers or they'll just copy them. We can't just copy them because x is no longer in our integral, and so there's no x's to plug these x values into. What we need to do is we need to change them. So if x is equal to pi over 3, and we made the substitution that u is equal to tangent of x, then we'll know that u is equal to the tangent of pi over 3. Now the tangent of pi over 3 is the square root of 3, and so my upper limit, rather than being pi over 3, is now the square root of 3 because that's a u value. My lower limit was 0, so if x is equal to 0, my u will be equal to the tangent of 0, which is equal to 0. That's my lower limit. Okay? Again, change your limits because we're starting with x values, we need them to be u values. We just use our substitution to make that choice. We can now solve this normally. We can now substitute this in. We can now take an antiderivative of u, which would be 1/2 u squared from 0 to square root of 3, and that's going to be equal to 1/2 of the square root of 3 squared minus square root of 0 squared, which will give us 3 over 2. Okay, one more example. So we want to look first, what do we need to do for our u? What should be our u? Now notice all of this down in the denominator. Again, we want to think about this one most likely as 1 over u. Now let's check that. If we say u is equal to x squared minus 4, that will give us du of 2x dx. Notice what we have here. We have an x dx, so the only thing is that 2. We can make this 1/2 du is equal to x dx for our substitution. So 1/2 du, our integral of 1 over u. Again though, we have a definite integral here, so we need to change these limits of integration. We'll look at when x is equal to 1, and we'll look at when x is equal to 0. We'll use the substitution that we have up here. We know that u is equal to x squared minus 4, or negative 3, so 1 would become negative 3. The 0, u is equal to 0 minus 4, negative 4, and so our lower limit is negative 4. We then take an antiderivative of 1 over u, that'll be our natural log function again. Make sure you use an absolute value. We're going again from negative 4 to negative 3. And it's easier to do that substitution rather than substituting this back in. We'll just substitute in that -3 and -4. Since its absolute value is just going to be natural log of 3 minus natural log of 4. If we know our rules for natural log, that's going to give us 1/2 of the natural log of 3 over 4.